I'm Daniel Parks. I'm part of the IBM Storage Ceph product management team. I work in object storage. And today we wanted to touch with you the Zero Trust Lakehouse topic. I have also Kyle here in the slides that is here. I stole his slides, no? So I had the decency of putting his name here, so I don't feel that bad for stealing. But yeah, so let me show you the agenda. So the idea of what I wanted to cover with you today is give you an introduction or some pointers of why Ceph and Ceph object storage can be like the perfect match for your analytical and also your ML AI workloads. Then we will introduce and talk a little bit about the Lakehouse architecture, and especially some of the challenges that we have when we work with the Lakehouse. One of them is governance, for sure. Governance is like a huge topic. We're going to try today and focus on access control. And once we present the problems that we can have trying to work around governance and access control, we will talk about how open source table technical catalogs like Polaris can help us with this problem, can give us an option to provide the required security and access control for our Lakehouse. And finally, so we don't go to sleep and we have a lot of chances of things exploding or not working, we're going to do a live demo and see how that goes. I was testing it before, and the certificates had expired for the Ceph cluster for the endpoint, so I am using another cluster, and that cluster has failed OSD, so we're actually stretching it now and taking it to the limit, but let's hope everything goes as expected. Okay, so moving forward, here I have like 3 main points that I wanted to talk about. As you were mentioning before, now why Ceph object storage can be like a great alternative, a great option for S3 native, like open foundation storage for your analytical workloads. And the thing is that in the last years, there is kind of an industry trend by which open formats, and in this case, open tables like Iceberg, Delta Lake, Hoodie, have kind of gravitated towards object storage. And both of these together, open table formats with Ceph object storage, can really help you bring together all of your scattered objects in your data lake, in your object storage, can really help you bring them together and provide like a high performance Lakehouse. No? So the idea with our Lakehouse is providing warehouse features with a TCO of a data lake, something that is very affordable. As the main point for this, we have Ceph and Ceph object storage in this case. Ceph object storage is like with the scale-out architecture that it has by design, is like a perfect option that we can use for our analytical workloads. And also, as we mentioned, also AI and ML is also there. So we can really store structured, unstructured data. No? So we could have Parquet files for our tables. We can have multimodal embeddings. We can really store anything that we need in our object storage. And we are, let's say, expecting or requiring the endurance and the resiliency that we get from Ceph. No? That is really what kind of an enterprise solution for analytics requires. So it's a perfect match in that sense. And then in the innovation side of things, I wanted to also mention the great work that the community and the RGW team is doing in adding more and more features that are critical for analytical workloads that really are taking the object storage to the next level. So we don't want to just do like puts and gets and nothing else. We want to be closer to the data, to the workload, and provide extra features on top of that. Even right now, as we have like many features that can help. AAM policies, we have I don't know, encryption at rest, encryption in transit, bucket notifications that integrates with Kafka and also Knative, so you can have like serverless data pipelines. All of this is already there, no? And we can talk about object logs, and that's going to really help you in all of your different stages of your journey and of your data pipelines. So really, Ceph is a good match in that sense. Here we have a quote from Google in a paper that they have around the transition or the migration that they were doing from kind of a data lake approach into a Lakehouse. And I just wanted to remark a couple of things in the sense of how they have this vision or they have this view of how we need to push to durable storage component to address enterprise customer requirements such as governance, security, metadata management, and performance. No? And this is the idea, as we were mentioning before. Okay, let's stop thinking about object storage as like this cheap box that we can do puts and gets and we can store things. We need to go further than that. We need to ask more from our object storage. We wanted to be able to do push down, so really accelerating our queries. We want to have a cache that is going to improve the performance. We want to have a transport layer as Aeroflight that can help us improve the communications between the query engines. So we really want to be part of the analytical use cases to provide enhanced performance. There, we published a red book that is some books that IBM provides, and is for building data lakes, lake houses with Ceph. So the nice thing is that it has like practical use cases step by step on how in each part of your data pipeline, we could say, you actually can implement all of the object storage features that we have been talking about. They really fit, no, in the different stages of your data. Here I just wanted to provide at a very, very high level, like the architecture of a lake house. So at the top, at the highest layer, we have like our compute engines. There are here just listed some of them as an example, but the thing is that we want to be compute agnostic, because here we have some engines, but there are more and more engines appearing every day. So we really need to work with all of them. The thing is that all of these data query engines, they want to consume the same data sets. They want to access the same data sets. And really, for that to be possible, for them to be able to read our raw objects that are sitting in our object stores, we need some glue to bring them together. And that's really our open table formats. No? Like Iceberg provides metadata that is stored inside the same bucket with the data. And this metadata allows us to provide table views. So from our Parquet raw files, it's able to provide a table view for a SQL, so we can do kind of queries, selects, whatever is required to gain more insights into our data. And at the bottom, we have object storage, Ceph object storage. As we said, that's like the pillar, the foundation for all of our analytical workloads. And it doesn't really matter in what point you are of the journey of the data modernization of your analytical workloads, in the sense that, okay, I can maybe be still with kind of a legacy approach where you're using Hadoop and you have HDFS, and then you can use Ceph to move HDFS into object storage using the S3A connector. You can maybe be more forward in time, and you are already using open table formats, Iceberg, Dremio, whatever, you're already using a warehouse approach. Or you can even be working in the cloud, for example, with a Snowflake, and you want to query some data that is available on premises. That's also perfectly fine, and it works without any problems. Snowflake has external tables that you can connect on premises. And again, using open table formats, you can query, access the same data from different engines without any problems. The thing is, and everything like this sounds great, but it's not so easy, no? But you have so many engines, so many ways to access the data, that how are we going to control who can access what parts of your data. So, for example, who can insert in the marketing table, who can do a get in the, I don't know, whatever other table that we have. No? So that's the difficult part. And here I have a list of 3 main points that are a challenge. So the first one is that what users, or let's say that the consumers of the data expect is kind of database level access semantics. So they know about inserts, they know about select, etc. They don't need to know anything about bucket policies, ACLs in a bucket. That's completely transparent. So they just want to do a select to a specific tables and for things to work. Then when we talk to the security team, they want like zero trust. So they don't want any data leaks. You know that object storage and bucket leaks have been in the press recently. We really want to make sure that our security is high. And for that, we need to provide the security at the storage level, because that's the single platform where everything is the foundation of our data. So we don't want to have policies and 10 different engines with their own authentication method. We want to provide all of the authentication in a single place, and it needs to be at the storage layer. And finally, we need to maintain the performance and the scalability for our queries, because if we put kind of a proxy in the middle that is going to do authentication, that's very quickly going to affect the performance of all of our queries. So we need to provide those SQL engines or any other query engines direct access to our endpoints to get the best performance. So let me show you some of the challenges, because as soon as we start thinking about how we could fix this issue, we can see that it's not so simple. So for example, if we go into Kubernetes and namespace scope secrets, in Kubernetes, you normally have like a one-to-one relationship between a bucket and a namespace, and you have a secret inside that namespace that allows you to access the bucket. And that's all perfect and fine because you have isolation, it looks very good. But as soon as you need to share the data between different applications, between different teams, you run into trouble, no? Because the thing is thought to run inside the namespace. Then we need to share the access key and secret key between different namespaces. And you can sure hack your way or work around it, but it's not like a nice way to start, no? So out of the box, like our object bucket claims, or let's say namespace scope secrets, is not a good solution to trying to address this problem. Then we could say, okay, let's try and go with like an engine policy enforcement. So as we were mentioning before, we have these query engines, especially like the SQL query engines have kind of a common policy that you could maybe say, okay, let's try and fix and share the common policies between all of the engines. But as soon as you, for example, run a Spark job that you are also going to need, that Spark job can have direct access to your object storage, and automatically all of the enforcement that you were doing at the query engines has totally gone. So you can't really enforce anything here, no? So also this approach wouldn't work if you have Spark jobs in this case. Another one could be, okay, you can say, let's make sure that no matter what tool is doing queries, let's make sure that they have to go through our enforcement point, or our enforcement policy point, and we are going to put a proxy in front of our storage layer. But as we just mentioned before, this can work for a while. Maybe you are able to scale your proxy to a certain volume, but thinking about the amount of requests that analytical workloads do is just a case that is going to get in trouble very soon, and it's going to be an scalability bottleneck, and you're going to get into issues. So as you can see, there are problems trying to fix this issue, but to our rescue and to our help, we have technical catalogs or table catalogs that can help with this. Here, we're going to talk about the Polaris catalog, and that's what we're going to show you afterwards in the demo. But the nice thing that we can have here is that it can provide one of its many features is catalog credential vending. So the idea here is that you have Polaris catalog there in the left, and that's like your single source of truth, let's say, because the Polaris catalog knows about your schemas, your tables, knows about the principals, the users that can access, has grants to go to one table or another. So you have a centralized place where you have that information. And then how that goes is that, for example, in the NS purple, in the namespace purple, if you spin up a Spark job, it could be Presto, any other job, it's going to authenticate against Polaris, and Polaris is going to send back a credential token, an STS, a temporary credential token that is scoped only to access the table that that user has permissions to. So it's going to be least privilege approach, and it's also temporary because we're using secure token service that is only valid for a certain period of time. So once that engine, whatever engine it is, has the STS token, he goes to Ceph, to RGW, he presents that token, and then he can only access the objects that form a table with the permissions that he has. No? So it can be very granular, the grants, it could be insert in this table. There are many, many options that you can use for grants. It's very, very granular. And this is really what we need. No? We want to have temporary tokens, least privileged, and really very easy to share data between our different stages of the data. As we have here, raw, staging, and gold, we want to really control who can access what. Here we have an example of what kind of RBAC you can do with Polaris. We have principals that are kind of the users and principal roles that you can assign the users to. There's also the concept of catalog roles. I won't go too much into detail, but this is just an example of how we can actually do RBAC at different levels and also provide access, only read access to certain tables, write access. We can also have like catalog admins that are managing the actual catalog schemas, etc. So as we said, this can get as granular as you require. We also have the concept of namespaces, so we can have catalogs, and inside that catalog namespaces to break things down further. And the nice thing is that you can really enforce policy at any namespace or sub-namespace level, and that's going to trickle down into all of the tables. So if, for example, I configured one access to namespace 1, that user, that principal, will get access to all of the tables under namespace 1 or a sub-namespace. No? So it can be really granular, and we can really build kind of our organizational unit representation with catalogs and namespaces. And finally, I have here RBAC for granularity per table. This is what we're going to show in the demo. So the idea here is that in a single catalog that is going to be production, we have a namespace that is prod NS for prod namespace, and then we have a set of principals that are users, and we're going to work with Charlie and Alice just as the simple example that we're going to show in the demo. And the idea is that Charlie is the admin, so he's able to actually manage the tables, he can insert data, he can list tables, he can do admin stuff. And then we have Alice that is able to read the product table, and he's also able to write in the European and the EU table. So we're going to actually test this in the demo, and we can see how that goes. As we said, this is certain features that we have specifically for access control with catalogs, but there are many, many other things that we can work with that will be too much to cover today, especially when we want to show the demo. But you could have table optimizations to improve how your tables are performing, to improve, let's say, your small Parquet files, merging them together. There are all kinds of table optimizations that can also be taken care of from the catalog. Okay, so let me show you. This is a little bit the steps that we're going to follow in the demo, and I will talk you through it as I go. But just so you have this slide, and you also have here the link to the actual demo code if you want to run it, if you want to play with it. Kyle has done most of the work for the demo in any case, but I will talk you through the parts that we have there. Okay, so let me just jump into the demo here. I think that you can see this okay. I just have a wrapper to run things. So as we mentioned before, the idea is that the only thing that I have is an RGW. I have an RGW service running, and I have an account. So I created an account, and I have an RGW. The rest is going to be deployed as we go with Terraform, if nothing fails. Let's see. So the idea here first is that we're going to run the Ceph side of things of Terraform. So we're going to create an IAM user. We're going to create an S3 bucket that we're going to use to store our data. We're going to create the policies that we need. So all of this is going to be deployed by the Terraform provider. And again, the really nice thing that we have with Ceph RGW is that we have high fidelity with the APIs. So in this case, we're using the Terraform IAM provider, and it just works. No? Out of the box, you use the Terraform, and we are compliant, so it just goes ahead, and you can throw it in, and it's going to deploy all of the automation for you. So in this case, we are deploying Ceph resources. This is the variables that I passed into the Terraform, just so you see that I only need the account ARN and also the credentials for the account root user, no? The one that is going to be the admin. So this is going to take a while. It doesn't take too long, but it's actually going to start creating the resources in Terraform that we need for Ceph. And the next part is actually starting a couple of containers and then again using Terraform to deploy all of the Polaris stuff. No? The nice thing with the Polaris side of things is that there's a RESTful, there's like the Iceberg RESTful API, and Kyle helped there building the provider for the RESTful API that Polaris has, and this is really nice because then with Terraform, and you will see in a moment, you can create all of the things that you need to get going very easily. Okay, so we have the resources ready. We are now going to also get our containers running because we need to have a Polaris container. We're also going to deploy a Jupyter Notebook container. You can see here, no, we have Polaris. This is the RESTful API for the catalog. We have Trino. This is a SQL engine that we're also going to use. And we have the Jupyter Notebook that is really running Spark also. Okay, so the next step that we need to fulfill is actually create, so now we have Polaris running, but the metadata is empty, no? So we need to create some principals, some users. We want to create tables, schemas, all of the things that we need that I showed you before, so we can have like RBAC at a table granularity level. All of these variables are really filled in from the other playbook or Terraform, so you don't really need to do a lot in the variables here. So this is doing its stuff. As you can see, it's really quick. And these are all of the things that we created. I will just show you very quickly. But for example, we created our principals. So these are our users that we're going to use in the demo. It also created our tables. If you remember, we mentioned products, that Alice has access read to the products, and she also has write and read to the EU users. So as you can see here, it's really creating our tables, our schemas, all of the grants, everything with Terraform. There in a couple of seconds. Here we are actually exporting the tokens that we're going to use to authenticate. And finally, we should get a URL to actually do our RBAC demo with a Jupyter Notebook. No? So let's see if this works. Let's see here. That's better. I'm going to also run here. So you can see what I'm going to do is that we're going to have like the log from Polaris. So you can also see in all of the steps that we're doing during the testing that you can actually see the principal, the user that is accessing, and what part of the data he's touching. No? So it's really nice how that works. So first, we are going to just load the tokens into Spark. And we're going to create a Spark session. By Spark session, we're just going to create a session to be able to query the data. We're going to use 2 users. So you can see here that we are using Charlie, that is the admin, and we're also using Alice to to create another session. So then we can do queries from both users, and we can compare the access methods that they have, no, and what they are able to do. While we import the Spark job, it takes a little while because it's actually downloading kind of dependencies. While this goes, let me just make this a little bit bigger so you can see it. The output. Yeah, so this takes a while. As you can see there, it's created the sessions for us. Once we have the sessions, we can do actual SQL queries. So let's start. The first one that we have here is, okay, I'm Charlie, and I want to list all of the tables in my namespace, in my catalog, so I can just do a show tables. I should have access because, as we said, he's an admin. So as you can see here, I am able to list my namespace and all of the table names. I have products, I have EU users. So now as Charlie, I'm going to, let's say, do a batch load of data into the products table. So this also takes a while. The data is loaded. So now we can actually do a select, and we have here the new product names that it has added. And the nice thing that I wanted to show you is that while we're doing all of those operations, you can see live in the logs how I have a trace of the principal, so it's Charlie, and the actions that he's doing. No, you can perfectly see here how he was listing the tables, and then how he does a post. So he's actually uploading data to the product table, you can see here, and it was a 200. So it's a very easy to follow and to trace what is going on regarding authorization. No? So let me just continue a little bit here. So here we are switching users. Now this is Alice, and you will see that Alice doesn't have permissions to list tables. No? So she only has access to, let's say, insert data and read data from products. No listing table, so this should fail. You can see here that we get a forbidden because she doesn't have the grants. And if I go into the logs, you can see here how now I have a different principal. It's Alice, and Alice is actually trying to access and list the tables in the prod namespace, and you get a 403 access denied. Let's just move a little bit further. I'm getting to the end very quickly. But here I'm trying to insert into the EU user table. As we mentioned before, that's a thing that Alice can do. So you can see here that we did an insert and a select, and everything worked fine. Again, if I move into the logs, you can see here Alice doing a post to the EU user table. And as you can see here, I'm using Spark. You could be using 10 different SQL engines that you're still going to get these logs that give you a very good trace of what's going on. And here we are just going to do read from products. That is also allowed for Alice, and I will move forward. Here it's just doing, again, a select, but it's doing kind of a fancy graph. Well, not so fancy, a little bit ugly, but a graph anyway. And then this is the last part where we try to insert into the US user table. So this should fail because Alice is only based in the EU. She doesn't have access to the US tables. So if we go ahead here, you can see that we get a forbidden because Alice doesn't have access. So this is really nice, really cool in the sense that we are able to solve all of the problems that we were mentioning before. We are providing temporary tokens. We are able to provide RBAC at the table level. We can implement it with the help of the catalogs in the storage. This is actually under the covers working with S3 tags on the objects that form a table to give access, to grant access or deny access. And we are also providing direct path to the data for enhanced performance. So we are getting maximum throughput because once the engine gets the token, the scope token, he goes directly and talks to RGW. No? So you're getting maximum performance, no proxies in the middle. Finally, as you see, we saw here, that Alice is trying to do a get into the US users, and you get like a 403. Last thing that I wanted to show you, because you could say, okay, you have only shown Spark. Let's try very quickly with Trino, another engine that queries data. very lightweight, very nice. So here we have Trino. Let me make this a little bit bigger so you can see what's going on. Let's do a show table. Here I have logged in as Charlie. So I just want to do a very brief, I won't go through all of the examples. But as you can see, we can show tables. And again, we have logs. No? So even if I'm Trino, even if I'm in different engines, I always get logs. I get the principal and what's going on. No? That is really powerful. Let's just do one more. Select here. And as you can see, I can query and I can insert data from different engines without any problem. So it's completely compatible with the help, as we said, of Iceberg and the open table formats. We are just able to be compatible. It doesn't matter with what query engine we're using. And as you can see here, with all of the things that I have been running in Trino, I get the same exact logs. We have one thing to improve in the sense that in RGW, you know that we have ops logs. We have an audit log where we can see all the things that are going on our Ceph cluster. And I didn't show it here, but at the moment, what we get is that you get like an STS assume role was done, but in this case, the catalog that he's doing the assume role calls and then providing the scope token. And in the STS, the information of the STS, we just get that a catalog has done the call. But you don't actually see like the end user, the principal inside Polaris doing it. And that's the thing that is quite easy, or should be quite easy to modify and to get that information even in RGW. So you could go to Ceph and also have a nice tracking of what's going on in your storage, what principal inside Polaris, inside your query engines is accessing the data. Thank you. That's all I had. If you have any questions, we can talk afterwards. So thank you.